The letters USGS and the text Science for a Changing World appear in white over a black screen and then fade out. A coral reef teeming with colorful fish appears and the title appears, reading How Our Reefs Protect Us, Valuing the Benefits of U.S. Reefs. Video clips continue to show healthy coral reefs and vibrant marine life. An aerial view of the world appears, showing the northern tip of eastern Australia.
Reefs provide more than food. They also provide protection.
And the Great Barrier Reef appears in a sparkling blue.
Hurricanes.
The eye of a hurricane with spiraling clouds appears above the Great Barrier Reef.
Typhoons and cyclones form over the tropical ocean, sometimes doing serious damage when they make landfall.
Large waves crash against a reef and then a car is shown driving through salt water as a large wave washes over the barrier of the Malecon in Cuba.
Reefs dissipate waves' energy.
Underwater footage of large waves crashing above a coral reef show the destructive power of wave energy,
reducing wave height and slowing the water before it crashes into the shore.
A clip taken above water shows large waves crashing as they reach a reef while approaching the shore. An aerial view of Mexico's coastline appears.
Scientists created a computer simulation
with a computer-generated checker box grid over the coral reefs flickering into view
to understand how this works.
As the checker box grid fades, the camera zooms in as waves appear and slowly move toward shore over the coral reef.
So how
Scene
do we
changes
do
to show USGS research geologist Dr. Kurt Sterlazai speaking to the camera in front of waves crashing at Younger Lagoon on UCSC's Coastal Science campus.
this? It's a 12-step program.
A graphic showing the 12-step program of USGS briefly fades into view, showing 12 graphic vignettes, organized in 3 columns of 4 rows of graphics, starting with first column labeled hazards and downscaling waves to shore. 1. The first graphic, labeled A, offshore wave data south an island with north, south, east, west directions to symbolize swell direction. 2. The second graphic, labeled B, representative sea states shows a graph with deep water wave energy varying greatly around a relatively stable average over time in years. 3. The next graphic, labeled C, propagate to nearshore, shows the wave shadow of an island as high energy waves move around it. 4. The next graphic, labeled D, reconstruct shallow water wave data shows a graph with shallow water wave energy varying by the conditions of 500-year storms. Then, the next column is labeled ecosystem, reef flood modeling and shows the steps to evaluate the impact of ecosystems on flooding. 1. The first graphic, labeled E, 100-meter reef profiles shows many transects around the coastline of the same island as previous graphics. 2. The next graphic, labeled F, storm intensity shows a graph with wave energy increasing logistically as a function of return intervals in years. 3. The next graphic, G, effects of the reef shows 2 reef profiles, without reefs in red and with reefs in blue. 4. The next graphic, labeled H, flood frequency shows a graph with 2 logistic growth curves representing higher flooding without reefs in red and lower flooding with reefs in blue. The third and final column is labeled consequences, assessing impact and benefits. 1. The first graphic, labeled I, map flood zones shows an island with 2 shaded perimeters, one representing the flood line with reefs in red, which is closer to the ocean than the flood line without reefs in blue. 2. The next graphic, labeled J, assess exposure shows 4 equations, 4 cells, area, people, and built, each showing that we are calculating the difference for each respective factor with and without reefs. The people equation relies on census data and is labeled as such, and the built equation relies on HAGIS data and is labeled as such. 3. The next graphic, K, economic damage shows a graph with 4 colorful logistic growth lines representing damage in % by depth flooded in meters. 4. The next graphic, labeled L, assess risk reduction benefits shows 2 graphs, each showing logistic growth curves in red for without reefs and in blue for with reefs. The first graph is labeled people threatened and the second graph is labeled money threatened. The area between the curves is highlighted in green to represent the risk reduction benefits of reefs.
In 3 parts. First, identifying the hazard.
A text box appears, reading hazards, simulating nearshore wave hazards based on offshore wave energy measurements, and then an illustration of a large and powerful blue wave appears to its right.
Understanding the role of coral reef ecosystems in reducing that hazard.
A text box appears, reading ecosystem, model flooding impacts with and without coral reefs, and then an illustration appears to its right of a coral reef ecosystem with reefs in blue and with degraded reefs in magenta.
And then quantifying the consequences.
A text box appears, reading consequences, quantifying the protection benefits of coral reefs, and then an illustration appears to its right showing building profiles flooded with 3 different water levels. The lowest is labeled baseline water level. Above that, the next flood line is labeled 10-year flood level with a healthy reef, and the highest flood line is labeled 10-year flood level with a degraded reef.
We compute different storm return interval conditions, the 10-year, the 50, the 100, and the 500-year storm.
After Kurtster-Lazai says 10-year, a small blue wave appears in the lower left corner. As he says 50, 100, and 500, the wave grows and becomes very large for the 500-year storm condition.
Conditions. We do that all along all 3,100 kilometers of coastline.
A map graphic fades in, showing all U.S. coral reefs, including the reefs in Puerto Rico, U.S. Virgin Islands, American Samoa, Central Northern Mariana Islands, Hawaii, and Florida. The map shows annual expected benefits of reefs in dollars per kilometer, represented by a color gradient which shows high expected benefits in many areas, especially on the northern coast of Puerto Rico, around Oahu, and the eastern coast of Florida.
And then what we do is we model the flooding, and we do that under 2 sets of conditions. We do it with the current reefs.
The video of Kurtster-Lazai fades away to show an illustration of a large wave over a coral reef on the left and the profiles of many buildings on the shore to the right.
And then we model if reef degradation occurs.
A degraded reef in magenta fades in over the illustration of the healthy coral reef, and the profile of this degraded reef condition as it reaches the shore shows the degradation of the shallow shelf that existed under healthy reef conditions.
So we run our flood models with the current reefs and then with these future theoretical degraded reefs.
A large wave in magenta fades in on top of the blue wave illustration to demonstrate that degraded reefs cause increased wave height and power.
So then we can quantify that area protected by the reefs.
The camera zooms in as 3 flood lines are overlaid above the buildings on the right of the illustration.
For different storm intervals, and we can quantify them.
The building profiles are flooded with 3 different water levels. The lowest is labeled baseline water level. Above that, the next flood line is labeled 10-year flood level with a healthy reef, and the highest flood line is labeled 10-year flood level with a degraded reef.
That at very high precision, specifically at 10 square meter intervals.
A checkered transition, representing the high precision of this modeling, reveals an aerial image labeled as San Juan, Puerto Rico, showing 2 flood profiles for conditions with reefs in blue, which is closer to the water, and conditions without reefs in red, which extends far past the beach and amidst the houses, showing that flooding without reefs would endanger a large area of infrastructure in this image.
Along all 3,100 kilometers U.S. shoreline. So what have we found? U.S. coral reefs provide over $1.8 billion of protection annually.
The map graphic shown before, representing annual expected benefits of reefs in dollars per kilometer, fades in again with the text beneath that says 1.8 billion.
Annually, they protect over 18,000 people from flooding annually.
An infographic showing multiple human figures appears along with text that says 18,000.
And over $5 billion are protected for the 100-year.
Text appears that says $5 billion protected by reefs during the 100-year storm.
Basically, those losses would double if the coral reefs were degraded.
The illustration with the coral reefs and building profiles reappears, and an additional equation is overlaid, showing that 1 meter of reef height loss can result in a quadrupling of wave power and cause a doubling of flood damages.
Across the U.S., coral reefs are struggling.
The illustration fades out and the scene changes to show UCSC Ocean Sciences professor Dr. Mike Beck speaking to the camera on a beach in front of waves crashing at Younger Lagoon on UCSC's Coastal Science campus.
But the good news is that they can recover, particularly if we find the resources to help manage them better. This new study, by helping to quantify the benefits of coral reefs, can help us find the opportunities to fund the needed conservation and restoration. We can use these results to help inform the recovery spending after the hurricanes from 2017. That represents $100 billion in funds that could be used to help restore and recover our national natural defenses.
The letters USGS and the text Science for a Changing World in white appear over a black screen and then fade out. The words in cooperation with appear and fade out. Text appears. Reading these results can be found in the recent report by UCSC and USGS. Learn more at coastalresilience.ucsc.edu and a link to the USGS report included in the detailed description for this video. Text appears. Reading thanks to the Cal Academy of Sciences for video and images from Expedition Reef along with the Cal Academy logo and a link to find the full Expedition Reef video which is included in the detailed description for this video. A logo appears. Reading Jesse Kendall Bar Art and Photography with the kelp illustration and jessykb.com.